Yo, what's up all my cool cats and cougars? This is the Unit 3 test review party. So question number 1 says, give the coordinates of j prime under the conditions stated, and it has 4 conditions right here. So we're going to start by taking a look at j prime. Or sorry, we're going to start by taking a look at j. Here's Mr. J. What's up, J? And it's going to be going through some changes. And the first one is a reflection over the line y equals -3. So the first thing we should do is find the line y equals -3. We've said it many times in class. The line y equals -3 goes through the y-axis at the point -3. So it's going to go through the y-axis at -3. That line looks like this. It's a horizontal line. There's y equals -3. All right, so we're going to take j and we're going to reflect it over that line. So in class, we learned that a reflection is a mirror image. It's going to flip over that line. So if it's 1 unit from that line, it's going to be 1 unit. The image is going to be 1 unit on the other side. So j was the pre-image, j prime is the image, and there it be. So the coordinates of j prime after that transformation would be a 1 on the x-axis still, just like it was originally. But the new y coordinate, after it's flipped over y equals -3, instead of being -2, now it's -4. So there's the coordinates of j prime. I counted the x coordinate, 1. I counted the y coordinate, which was -4. Very cool. That's how you do it. You identify the line of reflection, you flip it over, and then you count your new coordinates. So up next, we have a reflection over y equals -x. All right, this is that fun diagonal line. Y equals -x is like saying, hey, I've got a slope of -1 and a starting point at the origin. So this is that diagonal line with a -1 slope. So we're going to graph that. All right, so there's my y equals -1 line. Sorry, y equals -1x, my bad. Y equals -1x. It's early. So there's that line, and I'm going to flip j over that line, and you can probably already see where it's going to end up. Well, it's half a unit, it's half a diagonal from that line, so it's going to go half a diagonal on the other side, and the coordinates are going to be 2, -1. So my new j prime is going to be 2, -1. All right. So, ooh, I forgot to do my coordinates for the first one. It was 1, -4. All right, guys, so that's how we do these things. The next one says a reflection over the line x equals 4. X equals 4. So x equals 4 is going to be the line that goes through the x-axis. Here's the x-axis at 4. There's 4 on the x-axis, so we need to make a line going through that. There it is, x equals 4. So it goes through the x-axis at 4. Now we're going to take j and we're going to reflect. Oops. So since j is, let's see, 1, 2, 3 units from that line, go 3 units on the other side. 1, 2, 3. There's our new j. And the coordinates for that new j are 1, 2, 3, 4, 5, 6, 7, comma, -2. I know I've got a big mess going on over here. I don't really want to erase it because I don't know if it'll stay on the video. I don't know how that works. But our last part says a translation, which means instead of flipping it over a line, we're going to slide. We're going to slide it. So we need to know what this means in words. X minus 8 should mean something to you. It either means left or right. And because it's minus, it's going to mean left. And then y is going to mean up or down. And since it's positive, it's going to mean up. So we're going to go left 8 units and up 1 unit from our original j, which is getting messy. I'm going to show you 2 ways to do this. The first way is just to count. Take your original j, go left 1, 2, 3, 4, 5, 6, 7, 8, and up 1. And there you go. There's your new j, which has the coordinates of -7, -1. That's one way to do it. -7, -1. That's not the only way to do it. I could have taken the original coordinates for j, which were 1, -2, and I could have applied that rule to it. I could have said, okay, take your take your 1, your x coordinate, and subtract 8. Well, 1 minus 8 is -7. Then I could have taken that -2 and applied my rule to it. I could have added 1. -2 plus 1 is -1. So I didn't have to do it on the graph. In fact, it was kind of less messy if I just applied the rule. But whatever you do, just do it right. Up next, okay, we're still using the same graph. If point L is reflected across the x-axis, so let's identify point L and the x-axis. Point L, right here, the x-axis, right here. So if I reflect that across the x-axis, what are the coordinates of L prime? Let's count them up. So we got to count our distance to the line of reflection because I'm going to flip over that line. So it's whoa. It's 1, 2, 3, 4. It's 5 units to get to the line of reflection. So then flip it over. So it's going to be 5 units on the other side. So it's 5 units to get to my line of reflection. It's 5 units on the other side. 1, 2, 3, 4, 5. So my new coordinates, it looks like it's -6 along the x-axis. And then my y-coordinate is -5. So the coordinates of this point, L prime, are -6, -5. I could have also done that by looking at the original coordinates of L, which were -6, +5. And I could have used the rule that if I'm flipping over the x-axis, you change the sign of the y. So if you flip over the x-axis, whatever your coordinates are, the x is going to stay the same, and the y is going to change to be the opposite. So 2 ways to do it. You can use the graph, you can use the rule, whatever floats your boat. The graph is messy, but it's always right. What are the coordinates of g prime if g is reflected across that diagonal line, y equals x? So this is a positive x now, so that's going to be a slope of +1. Which means up 1 over 1, and that's the diagonal line that I'm making right now. Trying not to mess it up. All right, and we're going to flip G over that line. Well, if you look, G is only half a unit from that line. It's almost there. It's only half a diagonal from that line. Diagonal is the word I need to use. So it's going to only be half a diagonal on the other side. So it doesn't go far. It's getting super messy. So the coordinates for G prime, after it's been flipped over y equals x, is just going to be, looks like -3 on the x-axis and -2 on the y-axis. -3, -2. So remember, when you have y equals x, you're dealing with diagonals. You're counting diagonals. You've got a diagonal line. We said -3, -2. The other way to do that one is to use the rule. Y equals x is an easy rule. The y equals x rule, says all you do is switch the y and the x, and that makes sense because y equals x. It kind of makes sense. You're going to switch flippy-floppy the x and the y's. So if my original coordinates for g were -2, -3, which they were, after the rule, which says you just flippy-floppy x's and y's, it's just going to be -3, -2, which is what we got. So the rule for y equals x says take whatever pair you have and switch them. Okay, but I try not to teach you a lot of rules. I try to teach you how to use the graph because you always have graph paper on your FSA. Number C, if J is translated according to the rule, what are the coordinates of J prime? Now, since my graph has gotten so... I'm just going to apply the rule to the coordinates of J. I know from the last one, question, part 1, that the coordinates of J are, what did I say they were? 1, -2. So my graph is getting so messy that I'm just going to be like, all right, let's just do 1 + 5, because that's what my rule says. And we'll just do the y -2 - 4. So because my graph is getting so messy, I'm just going to use the rule. And the rule spits out a 1 + 5 is 6, and -2 - 4 is a -6. I can check my work by saying, okay, this would tell me to move right 5 and down 4. So I can check my work by taking the original J, oh, it's getting messy, and moving right 5, down 4. Right, 1, 2, 3, 4, 5, down 1, 2, 3, 4. And the coordinates would be 6, -6. I can see that on the coordinate plane there. So I did it right. I checked my work. It is all good. That graph is a mess. All right, 2 more here. If h is reflective of the line x equals -1, all right, so again, let's identify the line x equals -1. It goes through the x-axis at -1. There it is. So that blue line is x equals -1. And I'm going to be flipping, oh, I definitely wrote that in the way. Oh, well. We're flipping the line, or the point H over that line. So point H, you're going to be going 1, 2, 3, 4 units to get to the line. And you guys know it's going to go 1, 2, 3, 4 units on the other side. So my new coordinates for H, we'll call it H prime. The x coordinate is 3, and the y coordinate looks like it's 8. 3,8. And then last up down here, if E prime is the point, what is the line? Ooh, this is a good question. So this is saying, hey, I'm telling you that E prime is at -3, 4. -3, 1, 2, 3, 4. So what did I flip E over to get to E prime? So what I'm going to have to do is find the line that is right through the middle of those two. Okay, my first instinct is maybe it's the y-axis. I don't think it's the y-axis though. That doesn't look like it's directly in the middle. Let's see. So it's 1, 2, 3, 4, 5, 6, 7, 8 is the total distance. So that means I reflected over a line that was halfway between the two. So 4 units away. So if I did 4 units right in the middle, 1, 2, 3, 4, that would be this line right here. So I need to know the equation of that vertical line that I just drew. Well, that vertical line went through the x-axis, at +1. So that vertical line that we reflected over is x equals 1. All right, guys. There's question number 1. Number 2, this video is getting really long, but it's really thorough. And you can always fast forward, rewind, whatever. Fine. Question number 3 says, select all the rules for the translation of RST to R prime, blah, 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 blah. So to do that, I got to wonder how you go from your pre-image here to your image. Would a translation of left 6 and up 4 do the job? That's what this is telling me, left 6 and up 4. So let's see, let's take 1 point, left 1, 2, 3, 4, 5, 6, and up 1, 2, 3, 4. So left 6 and up 4. That worked for R. Looks like it'll work for S. Looks like it'll work for T. So I'm going to check that box. That definitely worked. 4 units right and 6 units down. No, that's not what we did. We did left 6 and up 4. So I'm going to go with a no on that one. The next one says 6 left, 4 up. That's exactly what we did. Oh. So I'm just put the check there. It's the best I can do. The next one says left 4, up 6. Did we go left 4 and up 6? No, we didn't. And the last one says right 6 and down 4. I didn't go right 6 or down 4. So those are the only ones I can choose. All right, number 4 says if a figure is translated with the rule right 4 and down 2, which translation moves the image back? Oh, so how would you go back to where you started? That's a cool question. Not crazy. If I moved right 4 and down 2, how would I go back to where I started? I would probably go backwards. I would go left 4 and then up 2. So which one of these says left 4 and up 2? Left 4 and down 2? Nope. Left 4 and up 2. All right, so I like answer choice D. These tell me to move to the right, so I don't like A or B. So we wanted to know back to the original. So it's got to be choice D. And question number 5, the last one. Thank you. Whew, this is a long video. Point P prime is the image of point P under a translation. What is the image of L under the same translation? Okay, so I got to see how I moved from 2 to get to 5 on P prime. To go from 2 to 5, I hope you're all saying add 3, add 3. Because if you are saying add 3, that's right. And then to go from 3 to negative 4, where'd you get negative 4? Because that's the coordinates P prime. What did you do to go from 3 to negative 4? You subtracted 7. So if it's a translation, then I've got to do that to all the points. So if I took L, which was 8 comma negative 1, and I wanted to find L prime, I've got to do the same stuff. I've got to do plus 3 for my x, or right 3. I've got to do minus 7 for my y, or down 7. So you just do the math here. 8 plus 3 means I'm going to end up at 11 on the x coordinate, on the x-axis, and negative 8 on the y-axis. So we just had to apply the same translation, because that's how you do translations. You apply the same rule to every point. Oh, well, this has been a 20-minute video. Wow. I hope you learned something. If you need to, go back and rewind, or come see me before school or after school or sometime. All right, good luck. Bye.